Okay, so let's start. We want to continue from where we left last time. Last time we were discussing the concept of time value of money. And we had said, what does the concept state? We said the concept of time value of money states that 1 shilling received today is better than 1 shilling received in the future. After we discussed the concept of time value of money, we also discussed the techniques. What are the various techniques of time value of money? And we saw there are 2 techniques of time value of money. One is what we called the compounding technique. Number 2 is what we were calling the discounting technique of time value of money. Compounding technique is where we were saying, if you are an investor and you want to invest a certain amount now, and you want to know how much would that amount be 5 years, 10 years from now, if the amount will be earning this particular rate of interest. To get that future value of a certain amount that is being invested now, then we said you do the compounding. Okay? Where we said compounding is adding. You invest 1 million now, it will earn interest at the end of the year. That interest will be added to the principal. Then the interest will earn plus the principal will become the amount of year 2 and so on. That's what we call compounding. Okay? You get the future value of a certain amount. That's what we call compounding. Then we also say, what about if you as an investor, you want to know, if I want to get 1 million 10 years from now, how much should I invest now so that it earns a particular rate of interest and I'll get my 1 million 10 years from now? How much should I invest now? So to know the amount you should invest now, for you to get 1 million 10 years later, then you need to get the present value of that 1 million. Of that 1 million. That is what we called discounting. That's what we call discounting. Discounting is where you get the present value of a certain amount. You get the present value. Good. We started with the compounding. We started with compounding, and I gave you the formula for compounding a lump sum amount. If you are investing 1 million now, how much will it be 10 years from now, earning a certain rate of interest? We said to get that future value, you take the present value into 1 plus r to the power of what? N. That was our formula for getting the future value, where you are investing a certain amount now and you want to know how much it will be in the future. Where you remember we were saying, suppose you are investing 1 million now as the present value, it will be earning interest at the rate of 10%. So we said plus 1 into 1 plus 0.1, which is 10%, maybe for the next 10 years. Maybe for the next 10 years. How much would that amount be? We said it will be 1 million into 1.1 to the power of 10. Let me recalculate it. Let me calculate it. Just redo it very fast. 1.1 to the power of 10. 1.1 to the power of 10. I multiply that by 1 million. That will come to how much? It will come to an amount of 2,593,742. 742. That's what you will get after 10 years if you invest 1 million now, and it will be earning an interest of 10%. Okay? Which means you are earning interest every year at 10%. Good. Then we went further and said, listen, there are some investments which earn you interest more than once in a year. Where we said you could be earning interest twice in a year, 3 times in a year, or 4 times in a year, or maybe monthly. In other words, we said, what is the formula where the compounding of the interest is done more than once? In other words, where there is a multiple compounding, where there are multiple compounding in a period of 1 year. Within 1 year, there are multiple compounding. Say, for example, if the interest is earned semi-annually, twice in a year, you invest 1 million now at a rate of 10%, but if interest is earned semi-annually, then it means there is interest you will earn at the end of the 6 months. Okay, that interest will be added to your 1 million. Then whatever you get at the end of the 6 month plus your interest, that becomes like the principal of the second half of the year. Then it will earn interest again for another 6 months. That is what we said. If you are earning interest more than once, meaning compounding is done more than once. And we saw the formula. If compounding is done more than once, the formula was a future value equals to present value into 1 plus r into 1 plus r. We divided r by m and we multiplied that by n. And then that n we had to multiply again by m. Our m was the frequency of compounding. Our m was the frequency of compounding. For example, we have just said if you are compounding semi-annually, meaning you are compounding twice. So you will take your r and you divide that by 2. You will take your r and divide that by 2 so that you get the rate per 6 months. Our r per annum was 10%. But now that you're compounding semi-annually, you divide the r by 2 to get the rate for every 6 months. If you're compounding quarterly, then you divide that r by 4 because you are compounding 4 times in a year. Then you multiply your n, which is the power there. You multiply your n, the number of years, by the frequency of compounding. If you're investing for 10 years and you're earning interest semi-annually, that means your amount will be compounded 20 times, which is 10 years times 2 every year. That means your interest will be compounded 20 times. Your interest will be compounded 20 times. If you're earning interest quarterly, 10 years, then it means you will be earning interest 40 times in a year. Okay, so we said, assuming you are told that yes, you are investing the same 1 million, earning 10%, but this time you are compounding quarterly. What will that amount become? So it will become 1 million into 1 plus. Our R is 10%. I divide that by 4. That is the number or the frequency of compounding. Then we multiply or we power that by 10. That is the number of years. Multiply that by the frequency of compounding, which is 4. So this will become 1 million into 1 plus 0.1 divided by 4 is what? 0.1 divided by 4, that will be 0.025. Then everything to the power of 40. 10 times 4 is 40. So this will become 1 million into 1.025 to the power of 40. Let me multiply that. 1.205 to the power of 40. If I multiply that by 1 million, so this will become 2,685,063. So if you are earning interest quarterly, after your 10 years, your 1 million will become 2,685,000. You can remember we said if you are investing the same 1 million but earning interest annually every year, your amount will come to be 2,593,000. So you can see, and we said this in our last class, that the number of frequency also helps to determine the amount you receive. The higher the frequency of compounding, we said the higher the amount. You can see you are still investing 1 million for 10 years, but in the first one, compounding was done annually. But what's this second one? Now compounding is done quarterly. So you end up receiving more. Good. So we did that and we did an illustration. We did that and we did an illustration. We even did a past paper question. We even did a few past paper questions. So from there now, we want to go to the second part of our topic now, and that is now what we are calling discounting. Now we want to discuss what we call discounting technique. And this is now how to get the present value. This is how now to get the present value. Okay, that's what we want to talk about now. Let me talk about the discounting technique. Now, discounting technique, I've told you, is where you want to ask yourself as an investor, if I want to earn 10 million shillings 10 years from now, how much should I invest now? How much should I invest now? So discounting is trying to get the present value, is to get the present value of a certain future amount. Good. Now, before I give the formula, just try and recall, we have said future value equals to present value into 1 plus r to the power of n. 1 plus r to the power of n. And of course, we are saying discounting technique, it is the opposite of compounding. It is the opposite of compounding. Now, so this time, I am not looking for the future value. This time, I'm looking for the present value. So I can now solve this equation and make the present value the subject of the formula. Let's try. This will mean FV, if I divide both sides of this equation, if I divide both sides of this equation by 1 plus r to the power of n, this will become, this is to the power of n, this will also side, this other side will be PV into 1 plus r to the power of n, and I divide that by again 1 plus r to the power of n. So you can see now that if I do that, this 1 plus r to the power of n will go and against that. Okay, that will go against that. This will automatically now leave me with PV equals to future value, divide that by 1 plus r to the power of n, the power of n. Okay, mathematically you also know that this can be expressed as PV equals to FV into 1 plus r to the power of negative n, the denominator, which is the same as taking 1 over the denominator, which is the same as 1 over 1 plus r. This is the same as this. Don't write yet. This is f into 1 plus r to the power of n. So if I take the reciprocal of that factor, this is what it becomes. It becomes 1 plus r to the power of negative n. That's what I'm saying. Mathematically, that can be expressed that way. Okay? So this is the formula that we shall be using. This is the formula that we shall be using to get the present value of a future amount. That is the formula we shall be using to get the present value of a future amount. Good. So, for example, let us assume that you as a company, you want to invest. No, you want to get as an individual, you want to get your 500,000 maybe 5 years from now. You want to know how much should I invest in order for me to earn 500,000 maybe 5 years from now, if that investment will earn me 12%. If I am to earn 500,000 5 years from now, if the investment will be earning 12% per annum, what should I invest in that fund now? So you get what we are calling the present value of this 500,000, which in simple we are now saying, to get that present value, it will be 500,000 into 1 plus 0.12, because 12% to that expression it will be 0.12 to the power of what? 5. To the power of negative, the power of negative 5. That is the formula. This will become 500,000 into 1.12 to the power of negative 5. So let me see what the amount would be. Let me see what the amount will be, this is 1.12, the power of negative 5. When I multiply everything by 500,000, that looks like an amount of 283, that is 283, 713. 283, 713. That's what you will get after. No, that's what you should invest now. That is what you should invest now in order to earn or to get your 500,000, in order to get your 500,000. So that is the formula. That is the formula for, listen, that is the formula for discounting a future amount and getting the present value and getting the present value. Now listen, just like I talked about when you are compounding more than once, when you are compounding more than once, the formula I've given you for the present value here, the formula I've given you for the present value is where compounding is done more once in a year. But it's obvious, therefore, if compounding is done more than once, then the future value, no, present value, will be future value into 1 plus r, okay, divide that by m to the power of negative n times m, just like the other formula. I've just converted this formula now. I've just converted this by dividing r by m. See, the formula was fv into 1 plus r to the power of negative n. But now we are saying if the compounding is done more than once, if compounding is done more than once, then you get the rate per period of compounding. If compounding is done twice, you divide r by 2 to get the rate per 6 months. Then you multiply your number of years n by the frequency of compounding, that you get the total number of compounding in that given period, maybe for 5 years and so on. So I'm still applying the same formula for where you are getting the present value of compounding once in a year. Then I'm saying if now we use compounding being done semi-annually, you divide r by 2. If you are compounding quarterly, you divide by 4. If you are compounding monthly, you divide by 12. And then you multiply n again by the frequency of compounding. You divide by n, frequency of compounding. Good. So before we put down the summary notes and we do a question now, before we do a summary note and do a question now, let me talk to some of you who are just new to this group, So please, for those who are new and for those who are even listening, watching, you may have some friends who are doing financial management and have not joined our online classes. Please tell them about our online class. We are offering online classes for financial management of the intermediate level, that is FM. We are also offering online classes for financial reporting of the intermediate level. You can tell them we are also offering advanced financial reporting of the advanced level. We are also offering financial accounting of the foundation level, and the one of ATD1 and ATD2. Those are the papers we are offering online classes for. We are offering online classes for financial management of the intermediate level, financial reporting of the intermediate, advanced financial reporting, and financial accounting. Okay? So tell your friends that we are offering these online classes. Okay? Good. Now, if you are watching this and you have not subscribed, to my YouTube channel, please click that subscription button please click that subscription button so that you subscribe. This will enable you to get notification whenever we post new videos into the YouTube. You will get notification those. Okay. Also, please, you can click the like button to like this video. Click that like button to click or to watch this video, to like the video, sorry. Click the like button to like the video. Okay. That's my appeal. Click the like button. And if you have not subscribed, please subscribe. Then I've said, tell your friends, these are the online classes we are offering. Now listen, if in case their friends are not able to join the live class, then they can also buy what we call the pre-recorded videos. They can also buy what we call pre-recorded videos, where they can watch the videos at their own free time, at their own pace. If they are not able to join the live class, then they can buy the pre-recorded videos for any of these subjects, Good. Then the other point is, for them to reach me, they can call me on this number, 0722 65 8875. 0722 65 8875. That is my number. You can call me, or they can call me on that number. They can call or text, then we shall be able to communicate. Good. So that's what I wanted to say before we continue. So let's put down the summary note of what we have said. So today we are starting with the concept of discounting. So let's put down the summary note on the discounting. So this is my information for those who have friends who have not joined or who you want to recommend. That is my number. You can reach me, and those are the subjects. Good. Now I've said, please like the video and click the subscription button. Good. Let's go back now and discuss or write summary note on the discounting. Put down the subheading. Put down your subheading, discounting technique. Discounting technique. You can even put in bracket present value. Discounting technique in bracket present value. Discounting technique, present value. Good. Discounting technique, present value. Now, maybe you can recopy this. We are saying here, you recall. This was our formula for future values. If you recall that, then you can now derive the present value. So from the future value formula, we are trying to derive the present value. So you can even copy that just to help you recall. Otherwise, the key formula is the formula which is down there. But just copy this to show you. Just copy that. So we are discussing the discounting technique. That is getting, can even say you are getting present value. Getting present value. Maybe you can add that so that you know what you are trying to get. Getting present value in bracket. Getting the present value. Okay, so that is the formula. So the technique is discounting, getting present value. Then we are recalling. Then from the recall, we are developing that. From the recall of the future value formula, we are recalling that future value formula. This is recall future value. So from there, we are trying to use it to derive the present value. So copy up to down there. Copy up to down there. Then we do an illustration. We do a question from your past papers. Copy that. And then we do a question from your past papers now. That is the formula. But the main one is the one I've put in the square or in the rectangle. That is present value equals to future value into 1 plus r to the power of negative n to the power of negative n. Good. Hope you are through with the copying. I hope you are through with the copying. Okay. If you are through with the copying, let us put down an example. Copy an example first before we do a past paper. Okay, I hope you are through with the copying. Okay, so copy this example now. Let's copy this example. Put down an example. Then you say this. Determine, put down this example. Determine the present value. Determine the present value of shillings 500,000. Determine the present value of shillings 500,000 expected after 5 years. Determine the present value of shillings 500,000 expected after 5 years. Expected after 5 years at an interest rate of 12% per annum. At an interest rate of 12% per annum. At an interest rate of 12% per annum. You're saying determine the present value of shillings 500,000 expected after 5 years at an interest rate of 12% per annum. Good. Let's do the calculation. We are saying our future value is 500,000. Our R is 12% and our N is 5 years. We have said present value will be future value into 1 plus R to the power of negative n to the power of negative n. So that's our formula for getting the present value. So this will be 500,000 into 1 plus 0.12, which is the rate, then to the power of negative 5, to the power of negative 5. This will be 500,000 into 1.12, the power of negative 5. So let me calculate that. What is it? It is 1.12, the power of negative 5. Then whatever I get, I multiply that by 500,000. This will be 283. That will be 283, 713, 713, 283, 713, 283, 713. Good. Finish. Now we do a question, a simple question from your past papers. Now finish. We do a simple question from your past papers now. Finish. We want to do a simple question from your past papers. Before that, let me be projecting the question I want us to do from your past papers. Let me project the question I want us to do from your past papers. Okay, there it is. I've projected a question 2. That's the one I want us to do, question 2A. It's a question that came in the month of April 2022. The question that came in 2022 April, question number 2A. Question number 2A, it says, James intends to accumulate 10 million in his bank account of 15 years from now. Required. Calculate the amount he should deposit now assuming that the bank is offering an interest of 5% interest per annum, compounded semi-annually. Compounded semi-annually. So this guy wants to get 10 million. How many years from now? 15 years from now. What's the rate of interest? The rate of interest is 5%, and it is being compounded semi-annually. It's being compounded semi-annually. Good. Let's do that question now. We are doing a question of April. This is a question that came in April 2022. Question number 2A. Question number 2A. Good. That's the one we are doing. We are given our future value to be 10 million. We are given our R as 5%, and our N, I think, was how many years? Let me confirm our N. Is it 15 years? Yes, 15 years. Good. Then I've told you, if it was compounded annually, now we are compounding semi-annually. So we are saying our present value will be future value into 1 plus R. Listen, now I divide R by the frequency of compounding, which is M, the frequency of compounding. Then I multiply that by, or I power that by N, negative N times M. Negative M times N. Of course, we defined the M last time, so we don't have to keep repeating. We know M is the frequency of compounding. M is the frequency of compounding. N is the number of years, or number of period. Then R is the rate per annum, which this time I'm dividing by the frequency of compounding. And I'm dividing the rate per annum by the frequency of compounding so that I get the rate per compounding. Maybe 6 months, what is the rate per 6 months? If it's quarterly, what's the rate per quarter? So on. So for this question, we are being told they are compounding semi-annually. Good. So let's get the amount now. Let's get the amount. So this will be present value equals to 10 million into 1 plus 0.05. That's our annual rate, 5%. I divide that by the frequency of compounding, which we are told is 2 times. So that means we are earning interest semi-annually. Then I multiply that to the power of everything to the power of negative 15 times 2, because we are compounding twice in a year. This is negative 15. Times 2. Well, that is the frequency of compounding. This will become 10 million into 1 plus 0.05 divided by 2. 0.05 divided by 2, what does it come to? 0.05, divide that by 2, it looks like 0.025 to the power of negative 30. The power of negative 30. So this will become 10 million into 1.025. 1.025, the power of negative 30. The power of negative 30. So this is 1.025 to the power of negative 30. I multiply that by 10 million. That means for you to earn the 10 million 15 years from now, you need to invest how much now? 4,767,426.85. That's what I'm getting. Good. So that's how much you should invest now for you to get the 10 million 5 years from now. Good. Okay, so let's now move on. Let's now move on to let's move on now to the second portion. Now, sometimes, listen, sometimes as an investor, you want to earn or you will receive, let us assume you will receive 1 million 1 year from now, you will receive 2 million 2 years from now, and you want to receive 3 million 3 years from now. So you want to know, how much should I invest now so that my investment will give me 1 million 1 year from now, it will give me another 2 million 2 years from now, and another 3 million 3 years from now. So how much should I invest now? Meaning, get the present value of that 1 million. What is it at 10% or 15%? What is the present value? 1 year from now, I want to receive 1 million. What is the present value now? You get it. Then again, you want to receive another 2 million 2 years from now. So how much should I invest now for it to give me 2 million from now? So you get what we are calling, again, the present value of your 2 million 2 years from now. What is the value now? What is the value now? Do the same for the 3 million in the third year. I want to receive 3 million shillings 3 years from now. How much should I invest now? So it will be, I take the present value of the 3 million 3 years from now. What's the present value? Once you do that, you get the total of all that, and that is the amount you should invest. So sometimes you may have your cash flows being more than one. This example I've done, we are receiving 10 million 5 years from now. Okay? Was it 15 years from now? But now I'm saying, what if you are to receive some future cash flows? Future cash flows. How much should you invest now for them to give you what you want? For them to give you what you want in the future. So what you do, you get the present values of those future cash flows. Get the present values of those future cash flows. Okay? That's what we're saying. 1 year from now, you want to invest or to get 1 million. What should I invest now? Maybe it will be 600. 2 years from now, I want to get 2 million. What should I invest now? Maybe it will come to 1.2. 3 years from now, I want to get 3 million. What should I invest now? Maybe it will be 1 million. Whatever it is. That's what we're saying. Then you add all those. Get the present value of those future cash flows. Meaning, you can do this in form of a table. You can do this in form of a table where you need a column for the year 1, year 2, year 3. You have a column of the cash flows. 1 million, 2 million, 3 million. Those are the figures you want to earn in the future. This is 1 million, 2 million, 3 million. Then you multiply that. The formula is the same. We want to get the present value. So it is still present value equals to future values is equals to future values into 1 plus r to the power of negative n. The formula is the same. Formula remains the same. It's only that we are putting the information in the table. Okay? Now, this figure, future value is 1 million. I want to multiply by 1 plus r to the power of n. Listen, this figure we are calling 1 plus r to the power of negative n. That amount is representing or represents what we call the present value, the present value interest factor. We normally call it the present value interest factor. That amount of 1 plus r to the power of negative n, whatever the r is, whatever the n is, that amount you get is what we call the present value. And we are computing using whatever rate. Okay? Maybe the rate is 10%. Good. So whatever you get, that factor is what we call the present value interest factor. Okay? Good. Maybe your rate is 10%. whatever it will be. Maybe your rate is 10%, whatever it will be. Once you get those discounting factors, that is 1 plus 10%, which will be 1.1 to the power of -1. That will give you this factor. Then you take the second year, 1.1 to the power of -2. That will give you the second factor. 1.1 to the power of -3. That will give you this third factor. Then from there, you will have another column called present values. You multiply now the cash flow with the discounting factor. Multiply the cash flow with the discounting factor. Multiply the cash flow with the discounting factor. Then you get this future present values. Then you add all of them. That's how we normally do it. If you have more than one future amount of the cash flows, you can get the present values by tabulating that in form of a table. Good. So let's put down a second example now. Let's put down another example. Then you say this: determine the present values. Determine the present value of the following future cash flows. Determine the present value of the following future cash flows at an interest rate of 10%. At an interest rate of 10%. So you have the table, you have a column for the year, you have a column of the cash flows. Year 1, year 2, year 3. This is the data the question is giving you. Our cash flow here is 800,000. Here it's 600,000. And our cash flow in the third year is 400,000. That is the cash flow we want to discount and get the present values Okay, good. Let's tabulate the table now. We have a column for year 1, 2, 3. We have a column of the cash flows. That is 800,000, 600,000. Then you have a 400,000. Then I get the discounting factor, which I have said it is the present value interest factor. And I've said in terms of formula, it's 1 plus r to the power of -n. 1 plus r to the power of -n. And our r is 10%. Then from here, last column will be the amount called present value. Last column will be the amount called present values. Good. Let me compute the factors, the discounting factors. Our first year, we are getting 800 at 10%. What is 1.1? Listen, 1.1, because our rate is 10%, 1.1 to the power of -1. 1.1 the power of -1. So the 1.1 to the power of -1, this will become giving me an amount of 0.909 to the nearest 4 decimal points, giving me 1. Okay, good. Then I go to year 2. I take again 1.1 to the power of -2. What does it give us? It is giving me a discounting factor of 0.8264, again to the nearest 4 decimal points. Good. Let me do the third year. I take 1.1 again, the power of -3. So I get that to the power of -3. This will give me 0.7513, again to the power of -3. Good. Now that we have got the discounting factors, let's multiply the cash flows by their discounting factor. First one is 800,000. I multiply that by 91. That is giving me a future present cash flow of 727,280. 727, 280. Good. Then I repeat for year 2. I get the cash flow, that is 600. Multiply that by the discounting factor, 8264. 8264. This is giving me 495, 840. 495, 840. 840. Good. Then finally, I take the 400. I multiply that by 75, 13. This looks like 300,520. When I add all this, what does it give me as the present value? What does it give me as the present value? It's 727, 280 plus 495, 840 plus 300,000, 520. This gives me a total of 1,523,640. That is the present value. Good. If you are to earn those future cash flows, then you invest that amount now. You invest that amount now. Good. That is where the cash flows are many, not finish. I want to develop the topic now. Finish. I want to develop the topic now. Finish. I want to develop the topic now. Yes. Finish. I develop the topic. So far we have discussed the compounding. Today we have discussed the discounting. Discounting where you are discounting a lump sum, and discounting where you are discounting where you are compounding once, that is annually, and discounting where the compounding is done more than once, multiple compounding. Good. Now listen. So we started with compounding. That's what we did in the last lesson. And listen, last time we were doing the compounding of a lump sum amount. I want to invest this money, 10 million now. What will it be in the future? So we were doing the compounding of that lump sum. Listen, what if you want to invest 1 million shillings every year from now for the next 5 years? What will that accumulate to 5 years from now? You want to invest 1 million shillings every year. What will it be 5 years from now? So you are still doing compounding, but now you're not just doing compounding of a lump sum amount. You are doing compounding of some regular amounts after a given period. The period could be 6 months, every 1 year, doesn't matter. But you are investing a regular amount. Those regular amounts, listen, those regular amounts are what we call annuities. Okay? What we want to discuss now are how do we get, listen, how do we get the future value? How do we get the future value of an annuity? Future value of annuity. We have discussed how to get the future value of a lump sum. I've just reminded you. Listen, the formula there was future value was present value into 1 plus r to the power of what? N. That was our formula. But now we want to talk about what is the future value of some annuities. Okay? Now, before I give you the formula, there are different types of annuities. There are different types of annuities. Types of annuities. We have two types. There is one type we call ordinary annuity. And we have number 2, this is what we call annuities due. Annuities due. Now, you are investing 1 million, 1 million, 1 million for 5 years. Now, this 1 million, listen, it depends. Are you investing it at the beginning of the year, or are you investing it in the fund at the end of each year? That's important. This 1 million that you keep putting in the fund, are you putting it at the end of every year, or are you putting it at the beginning of every year? If you are putting the amount of 1 million at the end of each year, that's what we call ordinary annuity. These are annuities that come at the end of the period. At the end of the period. Of course, we can say, we are not saying it's an amount you are receiving or paying. No, it's not an amount you are only receiving. It could be paying, but you are paying at the end of every period. Either you are paying somebody or you are investing somewhere, but you are investing at the end of the period, or you are paying at the end of the period. For example, you keep paying your employee's salary at the end of every month, That is an annuity that comes at the end of the month. That is an example of an ordinary annuity, e.g. salaries. Or if it's an investment that you are making, this is an amount you are investing, you invest at the end of the year. You invest at the end of each year. You invest at the end. You invest your 1 million at the end of each year. That's what we call ordinary annuity. The amount that you are investing at the end of each year, or the payment that you are doing at the end of the period, whichever the period, it could be end of the year, it could be end of the month, doesn't matter. But it is something that comes at the end of a given period. Number 2 is the second type of annuity, which we are calling annuity due. Annuities due. And these are those amounts that come at the beginning of the period. This is amount that come at the beginning of the period. At the beginning of the period. Let me give you an example. If you are a tenant, you normally pay your monthly rent at the beginning of that month. You pay rent at the beginning. So that is an annuity that you keep paying at the beginning of the period. If you have an insurance cover, you pay the premium at the beginning of the period. You pay the premium at the beginning of the period. So we are giving an example of annuities due, like rent and insurance premium. Insurance premium. You pay them at the beginning of the period. If it's an investment you are making, then it's an investment which is where the amount is invested at the beginning. The amount is invested at the beginning. If you are investing, then you keep investing at the beginning of the period. Good. Now, how to get the future values? Listen, how to get the future values will now depend on which annuity are you dealing with. Listen carefully. Which annuity are you dealing with? For example, if you are investing at the end of the month or at the end of the year, listen, the first one, you have an investment fund for 5 years. So the amount you will put at the end of year 1 will earn interest for only how many years? Only 4 years. Listen, Remember, you are not investing the 1 million at the beginning of the first year. You are investing 1 million at the end of year 1. So it will only earn interest in year 2, in year 3, in year 4. Are you getting? That's what we are saying if you are dealing with ordinary annuities. If you are dealing with ordinary annuities, that what you invest at the end of year 1 will only earn interest. If the investment is for 5 years, then you will only earn interest for 4 years on the 1 million that you invested at the beginning or at the end of year 1. What you invested at the end of year 2 will earn interest in year 3 and year 4 and year 5. Those are 3 years. But if it was annuities due, you put the money in the first year at the beginning of the year. If the fund is for 5 years, listen, you will earn interest now for how long? For 5 years, because you are putting the money in the fund at the beginning of the year. That's the difference. That's the difference on how much the amount will accumulate to. Remember, we are computing future values, but now we are discussing the future values of annuities, because these annuities will be earning interest differently. If it's annuity due, the first one you are putting at the beginning will earn interest even for that year. If it's annuity ordinary, first one you are putting at the beginning of the year will not earn interest that year. It will start earning interest for the remaining portion of the period. Good. Let me give you the formulas for each of these 2 types of annuities. Let me give you the formula, these types of annuity. Now, for ordinary annuity, the formula for getting the future values is this. Future value will be given by that annuity into 1 plus r to the power of n minus 1, everything you divide by r. Everything you divide by r. Okay? That is the formula for ordinary annuity. To get the cumulative amount you are going to earn for 5 years. You are putting 1 million, 1 million, 1 million in an investment fund for 5 years. How much will that 1 million become at the end of the 5th year? If you are putting the money at the end of each year, that is the formula you will use. Okay? Listen. Now, let me explain. When I was discussing, maybe I can put first the formula for annuities due. Let me first put the formula for annuities due. Let me first put it here. Then I will explain the reasoning behind. For annuities due, what's the formula? To get the future value, it will be annuity again into 1 plus r to the power of n minus 1, divide everything by r. Then once you do that, the same factor like the one for ordinary, but this time you multiply everything by 1 plus r. That is the formula for the annuities due. So these are the 2 formulas you have to remember. But listen, we are computing the future values. The only problem is this, that if the investment is for so many years, let's say 20 years, 15 years, then you have to remember this formula. Otherwise, if the investment is for 2 years, 3 years, and so on, maybe 4 years, listen, you may decide to ignore this formula. Listen, you may decide to ignore this formula and still argue the way we have argued for a single amount. Get my point? Future value for a single amount was 1 plus r to the power of n. That was a formula. So, if I am investing in year 1 for a period of 3 years, listen, let's make 4 years, then I can say the amount I'm investing by end of year 1, we are discussing the ordinary one. The amount I'm investing at the end of year 1 will only earn me interest in year 2, 3, and year 4. Are you there? So that is the same as saying this is 1m into 1 plus r to the power of n, which is what? Our n, which is 4, minus 1. Because it will not earn interest. The investment is for 4 years. Okay? The investment is for 4 years. But my 1 million I'm putting at the end will only earn me interest for 3 years. Second year, third year, and the fourth year. Plus. Second year, I put in another 1 million. So it will be 1 into 1m into 1 plus r. Our n is 4. Don't forget, our n is 4. Minus, this time, my investment of year 2 will only earn me interest for 2 years. Third year and the fourth year. So I minus 2. Then in the third year, I put in another 1 million into 1 plus r to the power of 4, which is our investment period. But the amount I'm putting in the third year will only earn me interest at the end of year 4. It will only earn interest in the fourth year, which means it will only earn me interest in one year, only once, by minus 3 plus. Listen, the amount I'm going to put at the end of year 4, because the investment is for 4 years, that will be 1 into 1 plus r to the power of 4. Listen, that will earn me no interest at all, because I'm investing it at the end of year 4. So I minus 4, okay, because I want to say it will earn me no amount. The amount I'm investing at the end of year 4 will earn me no interest. So the power earned there should be 0. Okay, this will means that this becomes, listen, this becomes 3, this becomes 2, this becomes 1, and this becomes 0. And of course, any power raised to 0 is 1. Okay? Good. But watch now. If this is for ordinary annuity, I have said, and the examiner gives you a shorter question, that this is an investment for 1 year or 2 years, 3 years, then you may decide to forget this complex formula here and just use the normal present value or future value formula. But now you take one amount, you get one amount, first one, and so on. Now let us assume, listen, let us now assume you are dealing with annuities due. I want you to get the difference. I am putting in 1 million every year. This means my 1 million here, I am putting it at the beginning. So that 1 million will earn me interest for how long? For 4 years. First year itself, second year, third year, and fourth year. So it will be 1 million into 1 plus r to the power of 4. So it will earn me interest for 4 years. Plus. Okay? This is the same 1 million again into 1 plus r. This second amount I'm putting in the second year will earn me interest in years 2, year 3, and year 4. Those are 3 years. The third amount I'm putting it at the beginning of year 3. That will earn me plus 1 plus r, the power of negative. I'm putting it at the beginning of year 3. It will earn me interest in year 3 and in year 4. So that will come to 2. Are you getting? Plus. This is the same as 1 plus r. No, 1M into 1 plus R, the amount I'm putting at the beginning of year 4 will earn me interest only for 1 year, so to the power of 1. So what am I trying to say? Listen, that when it is an amount of ordinary annuity, this we can express it to be future value is equals to present value into 1 plus R into N minus 1 plus present value 1 plus R to the power of N minus 2. Are you getting? Then plus present value into 1 plus R to the power of N minus 3, that way. So the first one I started by subtracting 1. Then I subtract 2. But if it's an ordinary annuity is due, then future value is just present value into 1 plus R to the power of N plus 1, present value into 1 plus R to the power of N minus 1. Then you come plus, this is PV into 1 plus R to the power of N minus 2. That's the difference. I hope you can see the difference. Okay? Otherwise, I'm saying, if the question is one where the examiner gives you an investment for 2 years, 3 years, it's an annuity for 3 years, 4 years, then you can use this formula if you want to avoid complex, because you can do this calculation. The only problem, it becomes a problem if the question is one where the examiner gives you a long period of investment, 20 years, 30 years. You can't keep repeating these calculations every year using the future value formula. So you have just to remember for annuity. And that's what we are now saying. This is the present value, future annuity. And I'm saying this is the same as this one. This is same as what I've said, future value equals to, let's use R into 1 plus R to the power of what? N minus 1. Because you are investing at the end. So you lose 1 year, you lose 1 year, you lose 1 year. Plus, this will be R year 2 into 1 plus R, the power of N minus 2. Are you getting? Then plus, this is R into 1 plus R to the power of N minus 3. Then plus R into 1 plus R to the power of N minus 4. That way. That's what I'm trying to say. Are you getting? Good. Let's put down. Otherwise, for this other formula, listen, we could even say here, same. This is same as. This is same as. Let me put down the summary formula now. It will be future value equals to R into 1 plus R, the power of N, the 4 years in total you're going to earn, okay? Plus R into 1 plus R to the power of N minus 1 plus R. Remember, now you are investing in the second year, you will only earn for 3 years. That's why you are seeking 4 minus 1. R into 1 plus R, 4, which is our N, you are investing at the beginning of year 3. So you will earn interest for only 2 years, minus 2, 4 minus 2. Good. Then finally, it will be R into 1 plus R. Let me put it down here. Plus R into 1 plus R to the power of N minus 3. That way. Okay? Good. So let's copy the formulas now. Let's put down something. Oh, we have to put down something first in terms of annuities. Let's put down. So have another subtopic. Have a subtopic. Future value of annuity. Future value of annuity. That is our subtopic. future value of annuity, future value of annuity, future value of annuity, future value of annuity. And then you say this, another subheading below that, types of annuities, types of annuities, types of annuities, types of annuities, types of annuities. Then you say this, number 1, ordinary annuity, ordinary annuity, then you put a dash, ordinary annuity, then you put a dash, ordinary annuity, then you put a dash. Then you say this, these are annuities, these are annuities that come at the end of, these are annuities that come at the end of the period. These are annuities that come at the end of the period. These are annuities that come at the end of the period. E.g., salaries, e.g., salaries. Maybe you can put another paragraph below that. These are amounts invested. These are amounts invested at the end of each period. These are amounts invested at the end of each period. These are amounts invested at the end of each period. These are amounts invested at the end of each period. Number 2, annuities due. Annuities due. Annuities due. Annuities due. Annuities due. Then you say this. These are annuities that come. These are annuities that come. These are annuities that come at the beginning of the period. These are annuities that come at the beginning of the period. In bracket advance, in bracket advance, in bracket advance. Then you say e.g., e.g. rent, e.g. rent, and e.g. rent and insurance premium, e.g. rent and insurance premium, e.g. rent and insurance premium. Another paragraph. These are amounts invested. These are amounts invested at the beginning of the period. These are amounts invested at the beginning of the period. Then I want you to copy this now. Then you have another subheading for ordinary annuities. Ordinary annuities you can put in bracket at the end. Ordinary annuities, just to remind you, in bracket at the end of the year. At the end of the year. Then copy this formula at the end of the year. The formula is annuities is equals to, no, formula is future value is equals to annuity into 1 plus r to the power of n minus 1. Everything you divide by r, then you close the bracket. Then you close the bracket. Then you close the bracket. Then maybe below that you can say same as, same as, same as. You can copy that formula. I have said future value equals to r into 1 plus r to the power of n minus 1. We were assuming our N is 4 years, so we are saying it's a shorter period. So your first amount will earn interest only for 3 months or 3 years. N being 4 minus 1, that's why we're saying N minus 1 plus R again into 1 plus R to the power of N minus 2, because if N is 4 and you're investing at the end of year 2, then you will only earn interest for 2 years. That is third year and fourth year, because you're investing at the end of the second year. That way. Are you seeing? Good. That is the formula for ordinary annuities. Before you put down the formula for annuities due, I want us to put down an example for ordinary annuity. Before you put down the formula for annuities due, let's put down an example for ordinary annuity. So after you have copied the formula and you have said same as, I've said this same as you can only use it when you are doing a small or a shorter investment. You will normally use the same formula for present value or future value, 1 plus R to the power of N. Okay? But when it's 10 years, 20 years, and so on, that becomes our problem. So you have to remember the formula. You have to remember the future, that amount of the future formula for annuity, which is 1 plus R to the power of N minus 1, everything divided by R. Then I've said, once you're through with the ordinary annuity, let's put down an example now. Let's put down an example. I'll copy this example now. Hope you're through with the copying. Now we put down example. We are doing the example for ordinary annuity before we copy the formula for ordinary annuities due. Copy this example. Copy this example. If an amount of 1 million, is expected to be deposited, if an amount of 1 million is expected to be deposited at the end of each year, for a period of 3 years, if an amount of 1 million shillings is expected to be deposited at the end of each year, the keyword there is end of each year, for a period of 3 years at an interest rate of 10%, at an interest rate of 10%, at an interest rate of 10%, comma, find the future value. Find the future value. So our annuity is 1 million. Our R we are given is 10%. Our N is 3 years. Let's get the formula first, long one. We have said future value will be given by that annuity, everything into 1 plus R, the power of N minus 1, you divide everything by R. That is our formula. Okay? That is our formula. Let's apply it. So our future value will be 1 million, which is the annuity, into 1 plus 0.1 to the power of 3 minus 1, everything divided by R, which is 0.1. Let's get that. Let's get that. So I get the solution in bracket first. Get the solution in bracket. I can start with 1 plus 0.1, that is 1.1. 1.1 to the power of 3. 1.1 to the power of 3. Whatever I get, I minus 1. So this looks like, if I may put it in simple, 1 million into, the numerator there will be 0.331. I now divide that by 0.1. Are you following? This will be 1 million times, what is 0.031? Divide that by 0.1. So I'm getting 3.31. So finally, I get an amount of how much? Times 1 million. This is 1 million times 3.31. I'm getting an amount of 3,310,000. 3,310,000. Good. That is the future value of that annuity. That is the future value of that annuity. Okay. Now listen. Suppose we use the shortcut, the one we are used to. Okay. Let's see. Let's use this one because the period is only 3 years. There we are saying recall. Listen, where we are saying recall, that future value is equals to 1 plus r, the power of n. So let's see whether it will give us the same answer. Let's see whether it will give us the same answer. Listen, this will be 1 million. We are getting the future value, 1 million into 1 plus, or we can even put it this way. Our rate is 10%, so it will just be 0.1 to the power of what? My investment in the first year, I am investing it at the end of year 1. Are you there? The period is 3 years, so it will only earn me interest for year 2 and year 3. Those are 2 years, which is the same as saying 3 minus 1. Okay? Plus. Then I invest another 1 million at 1.1. This one I'm investing at the end of year 2. It will only earn me interest for 1 year. Which year? The 3rd year. So it will be 3, which is our n, because the investment period is for 3 years, minus 2. So it will earn me only interest for 1 year. Finally, it will be plus into 1 million into 1.1. N is 3 minus 3. Give me a 0 income in that year. This will automatically be 1 million into 1.1 to the power of 2 plus 1 million into 1.1 to the power of 1 plus 1 million into 1.1 to the power of 0. 3 minus 0, 3 minus 3 is 0, which is of course 1. Okay? So this, if I may calculate, what is 1.12? Just want to demonstrate. 1.12 to the power of 2, I multiply that by a million in the first one. That will be 1210 plus. Second year, it will be again 1 million, 1.1, the power of 1. That is the same 1.1 times times 1 million. That gives me 1.1 plus. Of course, I've told you any power raised to 0 is 1. That will be 1 million. Let's add these 3 figures. That is 1210 in year 1 plus 1100 in year 2 plus 1 million in year 3. That comes to 3310. 3310. Is it exactly what we got earlier? Yes. I hope you can see my point now, what I was trying to demonstrate. This is possible when you are given a question of a shorter period, that you can just use the formula future value is equals to 1 plus r to the power of n. The only thing you must know is whether you are dealing with ordinary annuity or you are dealing with annuities due, because how they earn interest, those annuities differ. If it's ordinary, you are earning minus 1 year. Okay? If it's due, you are earning plus your current year. Good. That's the formula for ordinary annuity. Let's now put down the formula for, let's put down the formula for the annuities due. Let's put down the formula for annuities due. Come and see here for annuities due. Let's put down the formula. I've just talked about it. I just talked about it. Now we are just putting down the formula. And we have said future value equals to annuity into 1 plus r, everything to the power of n minus 1. You divide everything by r. Then once you do that, whatever you get, you multiply by 1 plus r. Put down that formula. Put down that formula. And I say it. Maybe you can even say here same as future value equals to r into 1 plus r, the power of n. Remember now your n is being invested at the beginning. So if our Rn is 4 years, so you will earn for 4 years. N will remain 4, which is 4 years, plus r into 1 plus r, the power of n minus 1. What I'm investing at the beginning of year 2 will only earn me interest for 3 years. Are you there? So, which means I take 4, which is n, minus 1. Good. Plus, this is r into 1 plus r, the power of n minus 2. Then maybe we can do the last one, n into r into 1 plus r, the power of n minus 3. That way, that way. Okay? So it's the same. So the difference is in the first year where n was minus 1, when it was annuity, ordinary, because you are not earning interest in that particular year. But this one you are earning interest even for the first year. Good. To finish, we want to put down an example. Finish, we want to put down an example now. Finish, we want to put down an example. Finish, we put down an example now. Finish, we put down an example. Then you can say this if you are through with the copying. Example. Example. Say this. Example. Say this. Using the previous example, and assuming that shillings 1 million is invested or deposited at the beginning of each year. Shillings 1 million is deposited at the beginning of each year. Shillings 1 million is deposited at the beginning of each year. Let's assume that. Same example. So we are saying here future value equals to annuity into 1 plus r, the power of n minus 1, divide by r, then everything I multiply by 1 plus r. 1 plus r. That is the formula. So let's apply the same annuity of 1 million into 1 plus 0.1, the power of, it was 3 years. Yes, 3 years minus 1. 3 years minus 1. Everything divided by 0.1. Then whatever I get, I multiply by 1 plus 0.1. Good. Let's see. This will be 1 million. You remember what we got in the bracket was times 0.0 what? I don't have to repeat that. It was 0.031. 0.331. 0.331. I divided that by 0.1. Then we shall now multiply everything by 1.1. This came to, you remember, 1 million into this came to be what? This came into 3.31. 3.31. Now, watch this. This is what we got for, listen, this is what we got for annuities ordinary. Listen, but now we are multiplying by 1.1. What am I doing? Listen, it's like I'm adding interest for another 1 year. Are you getting? The first portion was the same as ordinary annuities. That 1 million times 3.31 was for ordinary annuity. But don't forget, in ordinary annuity, we were losing 1 year interest because you invested the first time at the end of year 1. But this time, I am earning that interest. So it's like I'm multiplying this by adding another interest for 1 year. Are you getting? That's why we are multiplying by 1.1. Good. Let's do that. What am I getting? What am I getting? This will be 1 million times 3.31. 3.31, multiply that by 1.1. So I'm getting an amount of 3,641,000. 3,641,000. 3,641,000. Where I told you alternatively, let's discuss the alternative, which I said for a shorter question, you can still do it. Recall. Future value is equals to 1 plus r to the power of n. You come and say, my 1 million future value will be into 1 plus r, or 1.1. Now we can say we know. It will be 1.1 to the power of when? 3. Because you are earning interest for 3 years. Are you there? Good. Plus 1 million times or into 1.1, you are earning interest for 2 years because you are investing at the beginning. You will earn interest in the second year and third year. Good. 2 years plus 1 million into 1.1, you are investing the last one at the beginning of the third year. You will earn interest once. 1 year. Good. We see, what is this? These figures, we had already calculated them. Let me just pick them here. When it was to the power of 3, what was it giving us? When it was to the power of 3, it was giving me 12. No, we didn't have. So I have to calculate it. That is 1.11 to the power of 3. I multiply that by a million. I'm getting 1331 plus. Let me just multiply 1.1 to the power of 2 times a million. That is giving me 12 of 10 plus 1.1 to the power of 1 is just 1.1 times 1 million is 1.1. Let's see whether it will come to the same. This will be 1331 plus 12 of 10 plus 1.1. This is giving me 3641. Good. And it's the same. So we are saying where for the exam purposes is a shorter period, you can use the formula that you already can cram. That 1.1 plus 1 plus r to the power of n. But if it is a long question where you are given, you want to invest for 20 years, 30 years, which the questions are there, then we are saying you have to remember the formula. You have to remember that formula for annuity. Good. So that is all. Maybe for today we can stop there. Next time we shall do a few past paper questions now for annuities. We have done, listen, today we did discounting, and I've done a past paper question on discounting of a lump sum amount. Then from there, I've talked about annuities, and I've said there are two types of annuities, ordinary annuity and annuities due. Ordinary annuities are those which come at the end of the period, and annuities due are those which come at the beginning of the period. I have said for ordinary annuity, you lose interest for 1 month or 1 period. You lose interest for 1 period. Okay? For ordinary, that's for ordinary. Annuities due, don't lose any portion of interest. That's why the difference in the formula is that for annuities due, we are adding the extra part at the end to introduce that extra factor of the extra interest. To introduce that factor of the extra interest. Otherwise, for ordinary annuities, that is not there. Good. So remember the formula. It is annuity into 1 plus r to the power of n minus 1, everything divided by r. That is the formula for annuities ordinary. When you now say annuities due, then you multiply by the factor 1 plus r. Okay? Good. So maybe for today we can stop there. Next time we now pick up and do a few examples. Now we do a few examples. Now. Do examples on annuity. Do examples on annuity and even a past paper question. A few past paper questions now on annuities. Good. Otherwise, let me remind you, we have said, please recommend to your friends. First, I started by saying, if you yourself, you have not subscribed to my YouTube channel, please subscribe. 2, I said, please click the like button and like the video. Hope you have understood something and you have liked the class. So please click the like button. Then I've also talked about for your friends who have not joined the live the classes, the online classes, tell them we are having online classes for financial management, the one we are doing now. We also have financial reporting of the intermediate. We also have advanced financial reporting of the advanced level. Then I said we also have financial accounting of the foundation level and the one of ATD 1 and ATD 2. That's what I said. Then I also said if your friends cannot join the live classes, then they can buy what we call the pre-recorded videos, where they can get the videos and watch the videos at their own free times. They can get the pre-recorded videos. Then I also said, if you want to reach me, you can get me using this number, 0722 658875. 0722 658875. Maybe for today we stop there. Pick it up from there next time, where we do one example on annuity, maybe for a period of more than 10 years, 15 years, so that you don't use this simple formula. Okay? Then from there we do 1 or 2 past paper questions on annuities. Maybe we can do 2 for annuities. Then from there we develop the topic. So let's stop there for now. pick it up from there next time. Good. Make sure you have understood the topic, because this is the backbone of financial management. Time value of money is a concept that you should understand when it comes to financial management. Bye for now. See you next time.